So the problem today is sum of 4 values. So what's going on here? We have some array, and we want to find 4 values at different positions that sum up to x. This is very similar to yesterday's problem, sum of 3 values, except we're looking for 4 things instead of 3 things. This time, the size of the array is 1,000. So that means we can definitely afford n squared, but we still can't really afford n cubed, right? It's like a billion. 1 second, it's kind of sketchy. It would be nice to get an n squared solution, and we can actually find one. So we're given this array and some target, and we want to find 4 numbers that add up to the target, and we're supposed to give the indexes. So in this case, it's saying second, number 2, the 4th number 8, which is 10, 6th number 3, so up to 13, and the 7th number is 2, so that adds up to 15. Right, so 2, 8, 3, 2 adds up to 15. Right, we've repeated the 2, but there are 2's at different positions, so that's actually fine. And if there's no answer, it's going to be impossible. So this actually has a pretty similar solution to yesterday. So again, we're going to brute force over the first 2 values, and then we're going to look not for a single value to complete the sum, but for a pair of values to complete the sum. Right, so we're going to stick all the pairs in a map, and then once you brute force the first 2 values, we know what value, like the last 2 values should add up. We know what the last 2 values should add up to, right? It's just x minus the first 2 values. And so if we do have 2 values, with that sum, then we're done. And the point is that there's only n squared pairs, so you can sort of write them all down in n squared time. And then for each of the first 2 values that you brute force, there's n squared of those, and you can check in constant time if it's one of the pairs that you computed. And there's sort of a nice trick to only consider the pairs that are we need to deal with the fact that the positions have to be distinct, but that's not so good. So let's see how it goes. It'll be easier to show you how to deal with the distinct positions, sort of in the code as I talked about. So we're using nginx, and then we're using the values. And we're going to have a multi-map. So this is going to be for all of the pairs. We're going to have the sum of the pair as the key, and the indices of that pair as the value. So let's do all the pairs. So for all the pairs, the sum, and 2 indices, and notice that we just want the pairs where j is greater than I. Like we definitely don't want the pairs where the 2 indices are the same, because that's not allowed. Duplicates. Right, so this is what we want. And so we're going to brute force over the first 2 things. And the reason that we're starting with j instead of with I is that we are going to do a nice little trick to avoid getting duplicates. So the point is, once we're like if j is the second element, then the pairs that we want to look at are things that are bigger than j. So we're going to delete from the map all of the pairs that use j. Right, so j and anything paired, anything bigger than it, we can't use that pair anymore, so we delete it from the map. And anything left over in the map is going to be a valid, k and l that are bigger than j. And by the way, anything smaller than j, we would delete it on previous iteration of this tree. Okay, so now the only things in the map are valid for us. So we get it over j, we get it over I. So this is what's left. we're supposed to output them with one index, right? So when we select them in the map, we select them in one index, but I and j here are 0 index, so that's why I need to add 1 to them. Right. This is just the value of the map of this key, which is a pair. So this is like destructuring the pair. So we can print it out easily. And if we actually found something, then we can exit. And if we go through all the possibilities for I and j, and none of them worked out, then we know that it was impossible, and we can print that out. Now we need the includes, IO scheme, vector, map. We need utility because we do have pairs as the values of the map. Assert, and we are pair of integers. So 4 values. First compiler is. What is going on here? This is supposed to be not a vector, I was confused because I gave vector 2 template arguments, which doesn't make any sense. Insert takes only 1 argument, which is a pair, not 2 arguments. So I need to wrap a make pair around that. Okay. Now files. Okay. 1, 2, 4, 7. This is not the answer that they expected, but maybe it's still valid. 1, 2 is 5. 4 is 8, and 7 is 2. Yep. So we also found 3, 2, 8, 2. We just picked a different 3 than they did. Right, we have 1, 2, 4, 7. They have 2, 4, 7, 6. So we did 1 instead of 6, but 1 and 6 are both 3, so that's fine. Sum of 4 values. Cool. So it looks, it's kind of neat that this is still n squared, even though we were looking for 4 values instead of 3 values. And the point is that there's only n squared pairs. So, before we were like, in the previous problem, we were just looking up like a single element from the map. But now, you can pre-compute pairs in n squared, which is just as fast as we can brute force over the first 2 numbers. So anyway, it ends up still being n squared. If we were looking for 5 elements, we can do it in n cubed by like looking up the first 3 elements and then brute forcing a pair. Or if we were doing it for 6 elements, we could do it in n cubed by putting triples into the map and then brute forcing the first 3 elements. So like if you want to look up for n things, you can do it in floor, n. For k things, you can do it in floor, so n to the floor pair over 2 times. So anyway, that's this problem for 4.